In this question, bobsled riders have partially slowed down after they get to the end of the bobsled track, as you can see here. All you have to do is figure out how far does it travel before it stops. So, the first step in solving this problem is to find the normal force. To find the normal force, use the equation Fn is equal to gravity times mass times cosine of theta. In this case, however, as you can see from the kinetic model, cosine of theta is on the same plane as the kinetic friction and the motion. Therefore, we're using cosine theta instead of sine theta. So, plugging everything in, and you should get 9.81 times mass times cosine of theta for the normal force. Now we can find the kinetic force using the equation. The kinetic force is equal to the coefficient of kinetic friction times the normal force. Since joules are equal to 1 Newton per meter, you have to multiply the entire equation by distance. Therefore, the energy corresponding to kinetic friction is equal to the normal force times distance, which in itself is equal to mu times mass times gravity times cos theta times distance. The next thing to do is plug this back into the main equation. Kinetic energy is equal to the kinetic friction energy plus gravitational potential energy. Plugging this all back in, and you get this. Which, if you plug that back into the main equation, you get the following. Now we have a problem. You have two unknowns and one equation. To solve for this, you can substitute height for distance. As you can see using the triangle below, height is simply a component of the distance vector. Therefore, using distance times sine theta gives you the height. And by doing so, you can get rid of height from the equation and replace it with distance times sine theta. Now you only have one unknown variable. So therefore, you can rearrange the equation to solve for distance. Once you rearrange for distance, you get 1 over 2 times v squared all over 9.81, or gravity, times sine theta plus coefficient of kinetic friction times cos theta. Now it's time to pull out your calculator. For all those math lovers out there, this is your time to shine. If you do everything correctly, you should end up with an answer of distance being 31.242 meters.